Hi everyone, we are going to continue talking about the quadratic word problems. We've already seen this word problem in our last video, but we are going to actually ask different questions about it. So let me go ahead and read the question to you, get the context, and we're going to figure it out, okay? So a ball is thrown into the air with an initial upward velocity of 48 feet per second. Its height is given by the function h of t equals negative 16t squared plus 48t plus 4. Okay, so let's figure out the context. We are talking about a ball. So a ball is being thrown, okay? And another important aspect, no question has been asked yet, but the actual equation is really important. So h of t equals negative 16t squared plus 48t plus 4. So if we are to think about this, because I know sometimes these letters can confuse us, but we know that the h of t is our y equals, so negative 16, our t would be our x squared plus 48. T is like our x plus 4, okay? They kind of use these letters or variables to kind of represent what's going on. So h is height, and our t's here and here means time. And x, so x's are our times and y is our height. So if we like to, think about this like a graph, we know this is our x, which is time, and our y, which is our height. Okay, so let's go ahead and just get into the question. Okay, so what is the initial starting height of the ball? So there's a couple of important questions here. Initial, starting, okay? Initial and starting, where does it begin? Okay, where does what begin? The height. Height is our y. So where does our y begin? So we are talking about our y-intercept. We need to figure out our y-intercept. If we want to think about this like a graph, so if we have our x and our y, we know that looking at our equation, it is negative, our a is negative, so we know it's going to be concave down. So our graph is going to look something probably like this, okay? And if we know x is time and our y is height, I made a dotted line here just so we know that when we're thinking about this in reality, if this is time and if this is 0, we can't have -1 second, -2 seconds, -3 seconds. It always starts at 0, 1, 2, 3, 4, because time always goes forward. So that's kind of why I did a dotted line here, just to kind of show you. Now, where does it begin? Where does the height begin? So if we're thinking about this, our height is y. It begins here, on our y-axis, our y-intercept. And how we know what our y-intercept is let's look at the equation. I'm going to rewrite it again. So if we have h of t equals negative 16t squared plus 48t plus 4, we know that our y-intercept is our c value. It's always going to be our c value. And if we want to think about it in another way, when you are looking for your y-intercept, x has to equal 0. So our t's would be 0. So if we were to plug this in, so if we had h of t equals negative 16 t squared plus 48t plus 4, right? We would know that our t is going to be 0 and our t is going to be 0. So we're just plugging this in because x is t. And if we plug this in like that, and then we end up putting it into our calculator, just to check, just in case we forget that our c value is 4, I already have it in my calculator. Negative 16 times 0 squared plus 48 times 0 plus 4 is 4, which matches that. So our h of t equals 4. Our y is 4. So right here, we're kind of checking our work here. So our the ball's initial height is 4 feet. Okay? And if we wanted to write this as a point on the graph, you could also write it 0, 4, because our x is 0 and our y is 4. But here it is in a complete sentence. The ball's initial height is 4 feet, and it's our y-intercept right here, okay? Now, the second question. When does the ball hit the ground? So let me go ahead and rewrite our equation. So we had h of t, apologize. So we know what we're looking at. H of t equals negative 16t squared plus 48t plus 4. Now going back to our question. When does the ball hit the ground? Okay, ground. When I see the word ground, I should think of roots. I should think of our x-intercepts. Okay? And if we want to think about this like on a graph, remember we're kind of assuming that our graph looks something like this. Okay? Our roots, our x-intercepts, or our zeros, that's another word, let me write it over here, our zeros, are going to be right here. Okay? When does the ball hit the ground? Remember, this one doesn't really count because, you know, it doesn't matter, like in the sense that we can't go back in time, but these are our roots. This is the one that actually matters, because if we think about it, time goes this way, so we know that we need to figure out this one, when it hits the ground, okay? When it hits the ground. So, there is another video on how to find roots, but I want to show you a different way. You know, I'm going to show you how to figure out our roots using Desmos, okay? And this is great. So I have an iPad. You can find it on your computer and everything like that. So what I want to do is I went to desmos.com and I'm going to start typing in our equation. And it's going to go right here. So our equation was y equals negative 16 x, oops, I apologize. Negative 16 x squared plus 48 x plus 4. Okay, that was our equation. Remember up here, let's just compare. Negative 16t or x squared plus 48t or x plus 4. Remember, that's why it's important to know that these letters go. So, there are y and our x, okay? So we have just graphed it. Wow, let's go ahead and zoom in. And we can zoom in by using this little plus sign to figure it out. And look, here's our 0, 0. This is our starting point. Remember, so this point doesn't matter right here because it's a negative. But if we look over here, and all I do is just tap that point right there. And look, it tells me right here, your x value, and we'll write it down on this piece of paper right here, is going to be 3.081, 0. Okay, and just for the sake of this, I'll go ahead and write our other root, just so we know that we're doing this right. So we have negative 0.081, 0. Okay, remember, this is our x, this is our y. This is our x, and this is our y. Okay, now we have found that this one right here is our negative 0.081, 0 point, And this one right here is our 3.081, comma, 0 point here. Remember, this one does not count because time cannot be negative. So let's just mark it out. But it's okay to write it just so you know what you're looking at. And this one right here works. And if this is time, we know that it is going to be 3.081 seconds. Okay, so the ball hits the ground in 3.081 seconds. Okay. Also, we can see when we're looking at our graph, I know for our question number 1, we were looking at the initial starting height, or our y-intercept. You can actually see this on Desmos too. So we can kind of find it. I kind of tapped on it and look, a little dot came up, and let's check it. 0, 4. 0, 4. 4 feet. Okay.